The report states that NVIDIA will cut supply of GeForce GPUs by 30 to 40% in the first half of 2026. The report refers to memory shortages, with the rumor indicating that NVIDIA is attempting to adjust production of GeForce GPUs to account for memory shortages.
By all accounts, NVIDIA are going to try to force 8GB cards on gamers, whether they like it or not, and as we've covered on the channel countless times, these cards are already obsolete.
In real-time graphics, there is always something you can optimize, and the fact something can be done better doesn't mean there was no optimization done. From my time looking into VTube Studio, if anything, I see that many of its inefficiencies are related to how Live 2D works and not to VTube Studio itself. Do not use this video to go after Denchi. Got it? Hi, I'm Sui, a fox hacker VTuber who absolutely hates when companies make it hard to own things. A few weeks ago I have debuted this model, which was so lovely crafted by Tsuno and rigged by Kyoki. Little did I know, with the way UVs are laid out, it ends up using a lot of graphic card memory, and so, being a game developer in real life, I have decided to try and do something about it. Only to end up hooking VTube Studio itself, reducing the VRAM usage of textures 4 times. Keeping minimum VRAM usage is important, as many games nowadays target hardware with minimum of 8GB of VRAM. Running VTube Studio and OBS with quote-unquote plugins for VTube Studio on the same PC can easily end up using more than 2GB, which may result in a situation where there is not enough available graphics card memory to load necessary data to. Having done some research, I know that heavier VTuber models can even exceed 3GB of VRAM for textures alone. I work daily with Unity and I have created some Unity hacks for various games, so it wasn't too hard to find a function responsible for loading textures using dnSpy. Thanks to that, I know exactly the format VTube Studio is using when loading textures from PNG files. It's RGBA32 as defined by Unity with mipmap chain. I wrote a simple calculator using JavaScript that can calculate how much VRAM the model's textures are going to take. If you're interested, there is a link in the description. What you're seeing on the screen right now is also a list of how much VRAM each texture resolution takes with RGB32. So now that we have that out of the way, let's get down to how we optimize this. My model is two 16K textures, that 2.66GB of VRAM used for model alone. The tech we are going to use dates back to 1998. It's when S3 Graphics realized that there has to be a better way of packing textures into VRAM. Back in those days, Riva TNT had entire 16 MB of VRAM, and so S3TC was born. But for the rest of this video, I will be referring to it as BCN. BC in BCN stands for block compression. What BCN is a set of lossy algorithms for compressing textures for use in real-time graphics. It is extremely important to emphasize, unlike formats that need to be decompressed by a CPU when a file is read and then converted into uncompressed texture that is then displayed to a user, BCN textures are generally stored already compressed. Loading a file with BCN texture then loads it into RAM, and then it can be sent directly to VRAM. CPU no longer has to perform resource-intensive format decompression. Then, when a pixel is needed, a block of texture is quickly decompressed using hardware acceleration on a graphics card. This results in those formats often being equally efficient, if not more efficient, than just uncompressed texture due to their lower bandwidth requirement. And so, if only the cost of lossy compression isn't noticeable, it's a win-win. Getting back to VTube Studio, because it uses RGBA32, this limits us to BC3 and BC7. BC1 technically supports alpha, but the alpha is single bit, so it only can be used for cutout masks, which doesn't make it very well fit for VTube Studio. My first implementation of the hook was just executing compress method on texture to the object. This approach allows us to load the texture natively from PNG or whatever format it is stored in, and then once it's in RAM, not to be confused with VRAM, it is converted to BC3 or BC1 depending on whether it has transparency or not. This has actually two advantages. No new files have to be created, and it is mobile friendly since on mobile, Unity should execute etc algorithm instead. Mobile platforms do not support PCN. The downside are, the already long texture loading is now even longer since we've just added additional step to the pipeline, and BC3 is really not looking good with its results. Pause the video if you want to have a better look. It is technically possible to store a compressed BC3 texture, and loading that instead of PNG would be much faster, but as you can probably see, even though we have already reduced the VRAM requirement 4 times, the results aren't great. We'll need something better. That thing is called DDS and BC7. DDS is a file format used widely in video games. It itself can contain many different texture formats, including all BCN formats. It is well documented with an extensive header that allows us to figure out exactly what texture format it contains. The great thing about it is, as opposed to general purpose graphics format, textures in DDS are ready to be loaded to graphics card directly, and they can even have mipmaps bundled as well. The way I implemented it is we do additional check when loading a texture to see if DDS file exists in a folder with our original texture, and if it does, we load that instead of the original. Of course, it wasn't that simple. Unity by default only has a function that allows for loading data from JPEG, PNG and EXR files. DDS files aren't supported. I needed to write a class that will handle DDS data. Thankfully, since DDS already has raw texture after its header, it was only a matter of reading the main header, figuring out based on it whether there is a DXT extension header present, and if it is, read that one as well. Then, based on content of headers, load the texture data with load raw texture data method in a format and resolution defined in those headers. A result is significantly faster loading times and textures that should be, at least on stream or with video compression, indistinguishable from the original while using 4 times less VRAM. Biggest issue? DDS files are obviously not mobile friendly, and DDS textures need to be created ahead of time. BC7 compression is very complex, using many tricks to squeeze more information into a block of memory than BC3. I almost gave up on this project trying to implement it, relying on open source compressor from Microsoft, which always had a small difference around my model's mouth. Thankfully, switching to NVIDIA's texture tools resolved this issue. What you are looking at right now is 2 images taken from VTube Studio with maximum zoom scaled up additionally 2 times without filtering to make textures pixels even bigger. There is a wipe slider somewhere on this image. Left of it is the original model with uncompressed textures, and right of it is one with BC7 compressed. Can you spot it? Wait, let me make it easier for you. And how about a different model? Pretty neat for something that uses 4 times less VRAM, huh? Now, after all that, I will show you how to use my hook in case you want to use it. First off, you will need to go to my GitHub page for VTS Texture Compression project and into releases. There is a link in the description. You will then download a 7Z file and extract it using, for example, 7zip, but I think since Windows 11, Windows can also extract these types of files. Then move the files that you extracted to VTube Studio directory, and that's it in terms of installation. The hook uses Bepin X and Harmony X, just like many Unity game mods. After this, you will need to create a DDS texture file. You will need to go to NVIDIA's website and sadly register to be able to download NVIDIA's texture tools. After you have that installed, you launch it and then you load your model's textures in it. Set the format to BC7 RGBA, 8 bits per pixel explicit alpha, and then you scroll down and check flip vertically, since Unity's UVs, as far as I understand, are upside down. And save it as DDS file with the same name as the original texture. Repeat the process for your other texture files. You may notice that the file size of DDS files on your drive is bigger than the original texture file. That's okay, the DDS files take almost the same amount of space on your drive as they take in VRAM. If you load a program like MSE Afterburner or even Steam Overlay, you should be able to notice a difference now. For debugging, you can also look up a console log to see if everything else loaded correctly. Finally, I'm not intending on just sitting on this solution. Since DRAM prices are high and they will affect both RAM and VRAM prices for the upcoming years, especially with Nvidia prioritizing GPUs for AI and HBM memory over GDDR7, I will be suggesting implementing a similar solution to Denshi to hopefully help elevate this issue a bit. Maybe this way we can get those 8GB and 12GB graphics card to run for a bit longer, at least until the situation with prices returns to normal. And with this sad accent, I'm going to leave you. I'm Sui, a Foxhacker VTuber who just wants to keep the software running. If you want, you can check out my streams on twitch.tv/Sui_VT, or you can subscribe in here in case I make any other videos. I truly hope you have a great day, and I'll see you next time. Bye bye!